All right, I see folks still trickling in, but we're going to get started. We've got a jam-packed agenda today. My name's Jessie Lund. I would like to welcome you to the Electric Truck Bootcamp. This is our second of 10 trainings. As a reminder, the Electric Truck Bootcamp runs April through August as part of the lead up to Run on Less Electric taking place this fall. Run on Less Electric is a real-world demonstration of electric truck technology, and this boot camp is designed as a complement to that event to help the industry get up to speed on where this technology stands, as well as work through some of the challenges and opportunities that it poses for the trucking industry. Next slide. This is just a quick map to show the 13 participants of Run on Less Electric. These will be the 13 vehicles that we'll be tracking day to day over about a 3-week period this September. And you can note we've just added our final participant. DHL will be operating a Lightning eMotors van in New York City in September. So looking forward to working with all of these fleets as well as OEMs. You can see we've got a diverse group here, obviously geographically, covering both the US and Canada, as well as a diversity of vehicle types, duty cycles, climates, etc. So very excited to have you all follow along with us this fall. You can learn more at runonless.com. And the run will be kicking off at ACT Expo. Next slide. NACFE will also be hosting a half-day workshop at ACT Expo as part of this kickoff to Run on Less. If you'd like to join us at the Expo, Advanced Clean Transportation is now offering a discount for bootcamp participants. So you can use this code here at the bottom, bootcamp50, to save $50 on your registration. They're also currently offering a discount early bird rate. So if you want to join us at ACT Expo, we encourage you to register sooner rather than later. And real quick before we dive into today's topic, next slide, just an overview of what we've covered. We kicked off the Electric Truck Bootcamp 2 weeks ago with our first training on what's driving electric trucks. We learned a lot around a lot of the policy and technology developments that are really driving electric truck deployments, particularly here in North America. And if you missed that one and want to catch up, the video recording is now available on the website. So I encourage you to check that out. Next slide. A reminder of what is coming up. Our next training will be 2 weeks from today, where we'll be diving in even deeper on charging to talk about power management and resilience. And a reminder that after today's boot camp, if you would like to test your knowledge of all of the great content we're about to cover and work toward earning your electric truck badge, you can do so on the website on runonless.com. More info on that later. But for now, without further ado, next slide. Today we are all here to really talk about charging. And we've got a great panel lined up to talk about the basics and give an overview really of what planning and build out of this infrastructure looks like for the industry. Next slide. Before we dive in, I'd love to thank today's sponsor, Electrify Commercial. We'll be hearing from them on the panel today, and they've made some big announcements this week as well, which I'm sure Peter will speak to, but huge thank you for sponsoring today's session. Next slide. So, a couple housekeeping items before we jump in. You should see a question box in the upper right-hand corner of your display. Feel free to submit questions there throughout the webinar, and if we don't have time to get to them, we will try to respond afterward as well, or touch on them in another webinar or potentially at that ACT Expo workshop. You will also be able to access a recording of today's webinar as well as a copy of all of the slides. So feel free to put your pens down and just enjoy the ride. We'll be sending that out in an email to you after the session today. And there will also be a very quick 30-second survey at the end. We appreciate any feedback you're able to offer, so we encourage everyone to take that. And finally, if you do run into any technical issues, there's some contact info on your screen of how to resolve that. So today we're going to be focused on charging infrastructure, as I mentioned. And I want to highlight that NACFE did put out a guidance report on charging infrastructure back in 2019 called Amping Up. I would encourage everyone on the call to go check that out. There's a lot of great content in there. everything from what you see on the screen. We looked at the different components of charging, everything from hardware to the software to the maintenance, which tends to be forgotten. Next slide. And also put together a roadmap for fleets to use as they're thinking about how and when to think through their charging infrastructure build out. Next slide. We touched on some of the basics in that report, as well as including different power levels, different connector types, a lot of these things that can be a little bit confusing to beginners in the electric vehicle space. I will note that, again, this report was done in 2019, and so the industry has come a long way since then. We're going to hear a lot from today's panelists about how far we've come since that report and how some of these kind of basics are really playing out in the industry in terms of what fleets are actually using. Next slide. Since then, NACFE's also started charting out the different pathways for electric truck charging. As you can see on your screen, there are a lot of different options for how these vehicles will be charged. I will note that most all the charging that we're seeing today, with a couple exceptions, is number one, this fleet depot-based charging. And we're going to hear today about why that is. But again, there's a whole plethora of options. Some of these may have some challenges. For example, number 6, interstate rest areas, it's actually illegal to do commerce at those. So that's probably not a great option for the near-term future. But some of these other ones we are starting to see catch on. And again, we'll hear a little bit more about that today. Next slide. So as I said, we've got an expert panel lined up for you all today. These 5 folks on your screen have been really leading the industry when it comes to electric charging infrastructure for electric trucks, and not just thinking about how it might look, but actually being the ones working on developing it on the ground. So with that, I'm thrilled to turn it over to today's first speaker, Paul Stith. He's the Director of Global Transportation Initiatives at Black & Veatch. And Stefan, you can go to the next slide, I think maybe 2 more, and we'll let Paul jump in. Welcome, Paul. Thanks for joining us.
Yeah, well, perfectly. And, you know, it's super pleased to be here to chat and have all of our experts along with us who we're all going through this journey together. So anything we can learn, we can share, you know, postcard from the future, I'm going to kind of call it, like, well, what does this industry need to go with? So as mentioned, I'm with Black & Veatch. Black & Veatch is a rather large engineering, design, construction company. We offer consulting services on all of the same areas that we design and construct as well. And in this particular area, which would be the decarbonization of transportation, we really started 2012-13, and we've now done thousands of charging posts for our clients on nationwide type programs. You'll see a little bit more about that in a few moments, but I wanted to focus while I have it here is that it's an ecosystem about renewable energy, about battery storage, things that are going to make this fit into the grid. We're very far involved with all of our clients, be it utilities, be it the vehicle OEMs, be it the charging networks. It's a group effort, and we're working across all of the, call it the electron magic to make this happen. So let's go to the next slide. The kinds of programs that we've been involved in, actually in a really great proxy for medium heavy duty trucks, is transit. So we started in transit now coming up on about 6 years ago, and that's designing and deploying depots that have dozens or up to hundreds of buses, and everything from planning the interconnections for some of those large 200 vehicle type depots to building, like you see on there, New York City. One of the most difficult places, as Jesse mentioned, about out on the go, charging buses is really tricky. And we've done that in some of the hardest places to construct. More recently, we did have a nice announcement with Daimler and Joe's on with PGE about that first truck stop in North America for purpose-built for designing, for charging these types of vehicles. Let's move to the next one. Now, it's an ecosystem that we want to talk about. So we've got a really good sampling of across around that circle here, right here on this call for folks that are, you know, making it happen. And I want to just make sure that everybody understands a new dialogue, new vocabulary for many of these players, but if you don't have pretty much that whole circle and cast of team together, that you're not going to actually have success. You're going to be missing out on something. You may not have, for example, the government agencies and the permitting and jurisdictions. If you don't have managing of the charge levels, you might not really have success because you could be requesting too much power, for example, and that can be very expensive. And clearly, if you don't have the clean energy to that, that this is, a challenge to decarbonize transportation, full stop. So making sure you've got your energy side taken care of. And these things, by the way, they're not just, trucking. Again, it's actually public fleets, it's off-road, even mining and aviation. All of these have these big batteries in these vehicles, and they have the same challenges. They just kind of manifest a little bit different in each of the use cases. Let's go to the next slide. So now that journey, starting out from the very beginning, top left, and moving all the way down to the bottom right, there are a lot of steps, and that whole circle and cast of friends that are part of the soup, if you will, to put it all together, are going to need to participate right along this chart journey through time for each site. And it's not just necessarily per site, but it could be a large program. So be thinking about that you've got facilities teams, you've got your jurisdictions we mentioned before, you've got your utility. Every single one of those stakeholders is going to play an important role in the success of these projects. And it's a journey that you're going to start, and there may be some stops and fits with that in certain facilities it may have to a little bit slow down, but you have an entire portfolio and a transformation that's taking place. So getting from the beginning towards the end of that, just realize that there's a site approach and then there's a programmatic one. And always being, balancing the total cost of building these facilities with speed and future-proofing them along the way. Let's go to the next slide. So just how much energy are we talking about? This is a pretty graphic thing to think about, and these are, call them American-sized houses. So 22 of those, and the energy usage could equate to just one truck on the road. So that's a fair amount and might start to put into perspective. And that's just sort of say an average, and you could have more depending on if it's a slip seat and it moves like 24 hours a day vehicle, or it has more of a duty cycle in a long haul scenario with multiple drivers. Let's go to the next slide. So I mentioned energy before, cleaner, greener electrons, the theme, of course, and then look at your overall approach to it. You may be already procuring clean energy for facilities, and this is going to become the single newest, largest load to those facilities, and you may procure it on the go in one way or another, but you're going to have to roll that up into, call it the quality of the electrons, the price expectations, and then looking at things like resilience for these facilities. How is it that if the power of the grid is out, will you have enough capacity across multiple sites, or plan for some very super resilient sites with all the capacity? Let's go to the next slide. Now, I did slip this in here, and that's to talk a little bit about the char and megawatt effort that's been going on since 2018. And it's been a concerted effort. There are hundreds of folks that are participating. But I just want to emphasize that it is real, it is in prototype stage, and testing is underway, as well as an official global standardization, so that you can have some assurance about interoperability at the highest power levels. We're talking about returning vehicles to service in 20-30 minutes with rather large batteries. So technically, it's going to be able to go up to 4 odd megawatts of power into a vehicle. And today, I would say we'll start in the 1.5 megawatt range, which is dramatically more than light duty vehicles see today. Let's go next slide. We've been looking at this, sharing our thoughts across the industry. Definitely grab this. This is our second generation, which really starts to look at the whole ecosystem, including energy, to learn more and start your planning process. Next slide. And thank you very much. And we're always open to questions and looking forward to it.
Thank you so much, Paul. Perfect timing. Really appreciate that. It's a great introduction to what sorts of power levels and just what that infrastructure looks like to support these vehicles. And up next, we've got Peter Thomas, who is the Commercial Business Development Manager of Electrify Commercial. And Peter's going to share with us what Electrify Commercial and their parent company, Electrify America, have going on. Peter, over to you.
Thanks, Jesse. So as you mentioned, my name is Peter Thomas. I work on the commercial charging team at Electrify America. Really a pleasure to be able to speak with you all today. And let's get into it. So next slide, please. So first, a little bit of background about who Electrify America is. I think that the picture describes it better than I can. Over the past few years, we've really prioritized building out a nationwide network of open, ultra-fast charging. And now today, this slide is a couple weeks old. We've actually passed, as of last week, the 600 site mark. So 600 sites across the country aimed at passenger-sized vehicles, and all of these sites have ultra-fast charging capability. And what I mean when I say ultra-fast, 150 kilowatts or above charging, with a large number of these sites that have 350 kilowatt charging, so even higher than that. But we're not here to talk about passenger vehicles today. So what's happened with Electrify America is we've recognized that the same gaps that existed in 2017 and 2018 on the passenger vehicle side in terms of available charging exist now for heavy duty vehicles. And we've got some really exciting programs and projects that we're announcing both on the private depot side, but also public charging to serve these customers. So, Paul did a great job of laying out the life cycle of these projects, and he had a more exhaustive list of all the different pieces that go into these projects. I want to talk with you about these 5 items, and then key in on 2 at the end that I think are a little bit underemphasized when these types of projects are discussed. And by the way, these best practices, they are applicable in our minds across all charging projects, whether it's for passenger vehicles, transit charging, or heavy duty charging. So first, let's talk about program level planning. So this is really, the goal here is to come up with the optimal scope for you at your project or program that matches with the vehicles that you're receiving and the equipment that you're ordering. So, starting at the vehicle side, it's collecting the basic data that you need so you can design your site. So what trucks have you ordered? When are they arriving? What's the procurement schedule for those trucks? What's the charging capacity of those trucks? And then on an operational level, what's the dwell time of those trucks at your site? How long do you really have to charge them? And how long are the routes? What's the beginning state of charge that you're going to have on average when your trucks arrive at the depot? And then moving into the site level concerns. So once you have all that basic data, your vehicle constraints and your operational constraints, what local permitting agency are you going to have to be dealing with? Do you have a good relationship with them? Do you have an idea of what the timeline will be to receive your permit? And then, of course, really important, utility coordination. Are you familiar with your utility? Do you have a good ongoing relationship? And what are the utility rates that you're going to be signed on to once you complete your deployment? So that way you can map out both your upfront costs to get the site built, but then your ongoing operational costs and designing the site in accordance with some of the utility constraints. So, do you need to install batteries at that site, or is it not really a concern based on your local rates? So I'm going to talk just in general about design and construction. I think Paul would agree that these projects are relatively simple overall in comparison to some more complex construction projects. It's really pretty basic civil construction with some relatively basic electrical construction at the site level. So what I really want to emphasize on this slide is coordination across parties, just as Paul had mentioned. So having proper coordination with your local permitting agency, utility, and all the parties involved with design as you go through the design process, so that once your design is complete, the permitting agency, the utility are not seeing it for the first time. They're already familiar with it because you've already spoken with them about it, and it should be familiar, and there shouldn't be any unexpected late changes that could cause costs to rise and schedules to slip. Moving into construction, as with any construction project, the key here is coordination, effective management of the contractor on the ground, and ensuring that the construction is done in accordance with the design documents. So pretty straightforward. The commissioning process is really critical for these types of projects. And for us, what commissioning means is completing QA/QC of the installation to ensure that it was done in accordance with the drawings, that the electrical connections were done properly, so that once you flip the switch, everything is safe to operate and you're able to safely connect it to the network back end. So those are the main project areas that get you into operations, but I want to talk about two areas that I feel are a little bit underemphasized when these projects are discussed. And so those two areas are vehicle testing and then service operations and maintenance. So next slide, please. All right, so the message for this is the title. Pre-deployment and ongoing testing is critical. There's a number of different systems that have to interact, and it becomes relatively complex. And just as the slide that Jesse shown, all the work that NACFE has done to determine that really, you've got the vehicle hardware and the vehicle software, you've got the hardware, the charging hardware and the charging software, and then you've got the network backend that connects all of those things. So it's first really critical to do testing up front. So having in a staged environment, in a lab environment, the vehicles that you're going to deploy with the charging hardware they're going to deploy connected to that network backend, so you can do that testing up front to hopefully guarantee that once the site is complete, that everything is going to function properly. There's no surprises, and you don't have to have an extended testing period at the site to get it working. And then lastly, the nature of this hardware and software is such that over-the-air updates can be pushed on the vehicle side, on the charger side, as well as the network backend side. And these are, the idea, of course, is to constantly improve the services that this technology delivers. So it's very critical to have ongoing testing and some sort of a management system in place, somebody that's managing all of these different parties that could be pushing out these over-the-air updates, such that it's been tested again before it's pushed out into the field. So you don't arrive on a Monday morning after a software update has gone out and now your trucks won't charge. That's the worst case scenario. So bottom line, important to maintain testing and ensure that the testing has been done prior to the actual deployment at your site. Next slide, please. Okay, last, and this is something that again Jesse and NACFE have already emphasized, that it's important and it's relatively underemphasized overall when these projects are discussed. It's not the sexiest issue, but it's charger maintenance. You've done all of the work to get the site built, get the site in operations, but really that's only the end of the beginning, right? This is now you're in the operation stage. You need to ensure that the chargers work as well on day one as they're going to work in year 3 or even year 5. So the nature of this technology is that it's going to be out in the weather. It's going to go through constant charging cycles as it's used every day. And unfortunately, some electrical components could break. There could be issues that need to be quickly resolved. So because this is such specific technology, most fleet operators would rather not have dedicated internal staff that they're going to build up and maintain this to maintain this hardware. They want a service provider that can do that for them. So the main takeaway that I want you to gather from this slide today is those items on the last bullet. So no matter what system you put in place, the maintenance system that's there needs to have these components. So 24/7 engineering and diagnostic support, parts inventory that's local, and local contractors that are able to quickly get out to the site to fix any issues that come up that can't be solved remotely. Warranty management, so that you can ensure that if any issues occur with the hardware while it's still in the warranty period, that you're not paying for that if it should be covered under warranty. And last, and very importantly, that the party that you're partnering with to maintain your hardware is familiar with this hardware, and they're not learning as they go. They've dealt with these issues before, and they're able to quickly diagnose what those issues are and get them resolved. So that was a bit of a sprint. I hope that was helpful for everyone. It's a real pleasure, again, to speak with you. My contact information is below. I'd love to answer any other additional questions, and I look forward to the Q&A session shortly. So with that, I pass it back to Jesse, and I think Steve Block with ABB is next.
Absolutely. Thank you so much, Peter, for that. Excellent. Even if it was a sprint, a ton of great content there. And you're absolutely right. Up next, we're going to hear from Steve Block, the Western Regional Vice President of EV Charging Infrastructure for ABB. And Steve is going to talk with us about best practices for depot charging, which, as I mentioned earlier, is where we're seeing the vast majority of charging infrastructure be built out today. So with that, Steve, over to you.
Great. Thank you, Jesse. So as Jesse mentioned, I'm Steve Block, and I'm with ABB, specifically with our division that focuses on EV charging. Next slide, please. For those of you who aren't familiar with ABB, we're a very large public company. We've been around for over 100 years. We operate in over 100 countries with over 100,000 employees. We manufacture a lot of different products: electrical, industrial, automation, robotics. We do switchboards, panel boards, we do UPSs, but I specifically am involved in EV charging. And we've been doing that now for about 10 years and have deployed over 20,000 DC fast chargers in over 85 countries. Next slide, please. So as Peter mentioned, one of the biggest challenges and questions we get from customers all the time is, I'm buying X number of vehicles. How many charging stations do I need? What's the right size for those charging stations? And when I say size, I'm talking about power level in terms of kilowatts. So the first thing you need to do, obviously, is look at what you're purchasing today and what you plan to purchase. You need to understand the vehicle itself. You need to understand how big the battery pack is, and that's rated in kilowatt hours. That's how much energy the battery has. What is the voltage requirement of that battery? And what is the max charge rate of that battery? So how many kilowatts can it accept? So if you want to charge really fast, can you? Then you need to look at how many miles each of those vehicles is going to be driven per day, approximately. And how many hours are you going to have available to charge those vehicles? Are they going to come back during the day, or are they only going to be coming back in the evening and then charging in the evening? And then you need to look at electricity costs. And you're going to make decisions about when are you going to do this charging. Can you control when you do the charging to reduce the amount of electricity you pay? Or are you going to just have to charge whenever the vehicles come back, because that's the only way to run your business? And then you need to make decisions. What if a charging station were to fail and it takes a couple days to repair it? How would that impact your business? And what level of station redundancy do you need, or sharing, let's say, of charging stations? It doesn't mean you need one charging station per vehicle, but it will depend on your environment. We talked about charging fast, but sometimes there's what we call a mixed use environment. So you may find that during the day, you do need to bring those vehicles back and charge really fast, but you don't need to charge so fast at night. And so you need to take those things into consideration, as well as the available power at your site. You'll be working very closely with your local utilities to determine that. And then in the end, you'll make decisions around whether you're using what's called an AC level 2 charger or a DC fast charger. So next slide, please. So here are some of the basics about charging. So let's look at this vehicle that we have here. It has a battery that's rated in kilowatt hours. It has a BMS, which is a battery management system. The vehicle you purchased may or may not have an onboard charger. An onboard charger converts AC to DC and would allow you to use an AC charger. AC chargers cost a lot less, but the power level is a lot lower. So the charge rate's going to be a lot less. If you don't have an onboard charger or you need faster charging, then you'll have to purchase a DC fast charger, which can be the size of a refrigerator or even bigger. And that DC fast charger is going to convert AC to DC and provide that to your battery. Now, those cables, they have a certain rating in terms of amperage. Historically, non-liquid cooled cables were maxed out. Their max capacity is 200 amps, whereas a liquid cooled cable can provide up to 500 amps. So your power limitation of delivering energy to your vehicle is two things. One is the cable, and the second is the power rating of the station. To figure that out, we have simple physics formula that we all remember from high school, which is power equals volts times amps. Volts is actually the voltage of your battery. So it's important to find out from your vehicle OEM, what is the voltage of the battery? And then depending upon the amount of current that that station can produce, will tell you how much power you get out. So sometimes, as I mentioned earlier, that the cable can be the limiting factor, meaning you might have bought a charging station that can output 160 kilowatts, but the cable and the voltage of the battery may limit you to less power. Then to see how much energy you get, you take your power and you multiply it by how long you've charged that vehicle. So for example, at 80 kilowatts in 1 hour, you'll get 80 kilowatt hours of energy. And if a truck goes about a half a mile per kilowatt hour of energy, then you're getting about 40 miles of range per hour. And that's how you should think about it. What's the range per hour? Next slide, please. Now, one of the things that go wrong with some of these installations is we hire contractors and who are really great at installing all this equipment, but somebody forgets to check whether the site has a strong cell signal. And in order to operate DC fast chargers well, you need to have these stations cloud connected. They're cloud connected for usage data, for smart charging, but also for diagnosing issues, resolving issues, firmware updates. So you need to check with what's called a squid meter. If you don't have a strong cell signal at your site, it may be possible to use a cell booster. There are other options with Ethernet, but your organization, you have to talk to your IT department and verify that they will allow you to connect a DC fast charger to, or a level 2 charger to their internet. Next slide, please. A lot of customers are thinking about how do they charge these vehicles? Do they want to configure the station in what we call open access mode? That means any vehicle can connect to it, automatically starts charging. You'll still get usage data, but you won't necessarily be able to restrict access, and you won't know necessarily who's actually using it, meaning which vehicle or which driver. The other option is to use what's called an RFID or a mobile app that allows a driver specifically to authenticate using one of those mechanisms. The network provider can decide which drivers are allowed to use it, but even whether you want to restrict access or not, you'll actually get some usage data by driver. Or you can use the last one, which is called auto charge, which is a pre-version of something you'll hear of called ISO 15118 or plug and charge, which you'll start to see in the next year or two as standards get more mature. But basically the vehicle provides a unique MAC address that says, I'm a specific vehicle and I'm using your charging station. And then the cloud provider can collect all of this usage data and they can know specifically which vehicle got energy. Next slide. And that's it for me. So thank you, everybody.
Thank you so much, Steve. That was great, and tons of important tips in there for folks to remember as they plan out their charging. Up next, we're going to be hearing from Joe Collette, who is the Technical Manager of Charging Services at Portland General Electric, and he's going to be sharing with us some of an exciting project that PGE has been working on and recently opened. One of those few exceptions I mentioned at the beginning in terms of publicly accessible charging designed for electric trucks. So with that, Joe, over to you.
Great, thanks, Jesse. Good morning, everyone. I'm Joe Collette with Portland General Electric. Just a little bit about who we are. We're an investor-owned, vertically integrated electric utility serving about 900,000 customers in Portland, Oregon. And as Jesse mentioned, I'm going to talk to you a little bit today about a really exciting project that just opened about 2 weeks ago. Some public heavy-duty truck charging infrastructure, which we call Electric Island, that is actually the first of its kind site that was purpose-built for the charging of heavy-duty electric vehicles. And when we developed this site, starting back almost a few years ago now, we had the challenge of designing this site and this infrastructure for technology that is still under the development, that still doesn't yet, isn't commercially available today. And so I'll spend the next few minutes talking about some of the tricks and engineering design features we built into this site to really increase and enhance the flexibility and future proofing of this location. And next slide, please. And I think this is a great way to get oriented with the site. This bird's eye kind of drone shot of the location. And I'll talk about some of the high level attributes before taking a deeper dive into a few of the features. So the first thing that you'll notice is the semi truck. Well, you may notice many things. One of the first things I see here is the semi truck entering from the street. And that actually required a lot of planning, a lot of studies and design to make sure that that semi truck could make the turn into our site, maneuver to a fueling island, and exit safely in a way that didn't require the truck to enter another lane of traffic, in a way that ensured that that trailer wouldn't get caught on any of the charging islands. And so that's one place that you'll really want to spend a lot of time up front and on kind of optimal layout of your site. Once the truck is here, it'll have the ability to charge from any one of 4 charging islands. And today we have about 1.1 megawatts of installed charging capacity, but the site's been designed with headroom up to 5 megawatts. And I'll talk about some of the features that help us get that extra capacity as we need it in the future. Next slide, please. So we're going to zoom in on this equipment pad. And one of the things you might notice about this is that we don't have a traditional kind of concrete pad here. We actually have a suspended floor. We have metal grating supported by some concrete infrastructure below it. And what this does is it makes it really easy for us to route, reroute, change the routing of the conductors, the communications cables, all of the things that need to run between this equipment pad and the charging islands where the dispensers are installed. And that's really important for us because we're not sure what kinds of equipment is going to need to be housed behind here, what kinds of conductors and communications cables it might need, or really where we might want to place it. And so this provides us pretty tremendous flexibility and enables any point on this pad to connect to any point on a fueling island. So something important and something that you all might want to consider if you're deploying a site here before you know exactly what kind of infrastructure you might need. Next slide, please. So here we're zoomed in on the charging islands and on how these islands connect back to the equipment pad. And we're using precast concrete trenches here with cable trays instead of burying conduit in the ground. And this, again, provides us tremendous flexibility. An electrician simply has to remove the lids, and they can begin changing the routing or installing more cabling as we put different kinds of infrastructure in place. The other thing that you can kind of start to see in this slide, and we'll go into more detail into in a moment, is that the way that the chargers are mounted and installed on these charging islands is pretty unique. And you'll see we've got room for some more chargers, which will help us deploy different kinds of equipment and test things out. But we do something a little bit unique there as well to add flexibility. And next slide, please. And here's what we've done. We've actually cast in place a void into the concrete, or really a vault, and then installed a metal lid on top of it. And so if you're thinking about which dispensers you might want to use or which charging stations to install at your fueling islands and you're not sure, or you want there to be flexibility, maybe you're going to start with one brand today, you want the flexibility to change to another in the future, having this flexibility is really helpful. If we want to change the type of dispenser installed in the charging island, all we have to do is go to a metal fabricator and have a new plate made, and it will match the bolt pattern required to mount the equipment onto this pad, and it also enables the conduit to come up in any location that a manufacturer might require. And so this really makes it easy for you to have the flexibility, to have the choice, or even to begin your design process before you know exactly what you want for your charging equipment and your dispensers. Next slide, please. Finally, perhaps maybe a little less interesting than some of the other design attributes, but really important, is how we connect back to the electrical distribution grid. And what we're showing here are 2 transformers, and these kind of form the backbone of that 5 megawatts of total capacity at the site. And right now, the transformation installed in this location is rated for about 2 megawatts. Each one of those transformers can handle about a megawatt of capacity, but they're sitting on vaults that enable the installation of much larger transformers, 2.5 megawatts each, that really get us to that 5 megawatt level. And that makes it really easy for our utility crews to come out, pick up these smaller transformers and drop off a larger one as the site's power output increases in the future. And this is something I would encourage all of you to work with your local utilities on, to kind of right size, to future-proof, to install enough infrastructure there to make it easy to increase your power levels as the technology you're using might change, but also right size for what you're using today. And so this is how we've done it here, a combination of a transformer that's appropriate for the use today, but the underground infrastructure that will allow much more capacity in the future. Next slide, please. So thanks for giving me the opportunity to share what some of our learnings about Electric Island, and we hope that you all can see some of these tips and tricks and maybe apply them to build flexibility and future-proofing into the sites you might deploy. So thank you very much, and I look forward to your questions.
Thank you, Joe. Very exciting to hear about this project. Excited to check it out next time I'm in Portland. Thanks for all the tips and tricks, and we've definitely got a bunch of Q&A coming in, which we'll get to in a moment. But before that, last but certainly not least, we are going to hear from Alicia Gildy, the Senior Director Initiative Lead of Clean Fuels and Infrastructure at CalSTART. And Alicia's going to talk to us around a lot of the work she's been doing around corridors, noting that by their nature, trucks don't always come back to a Home Depot. It's not always so simple to build out charging infrastructure. And as we've heard, not that it's simple at the depot either. So without further ado, Alicia, over to you.
Great. Thank you so much, Jesse. And I am just so pleased to be a part of this incredible panel. And certainly I've learned so much already, and hopefully all of you are getting good information on what it means to plan out for a site for charging infrastructure at a depot. And now even hearing from our friend Joe about the Electric Island. And now I want to bring us even further out, looking at the opportunities to advance electric trucks, electric vehicles along corridors. Next slide. So we are seeing technology emerge for depot charging for medium and heavy duty vehicles. And we're seeing over time, in the last few years, we're seeing a lot of success. Now we can expect an opportunity to advance medium and heavy duty charging along our transportation corridors. And as we think about that, and we've learned about the complexity of designing infrastructure at a site, we now need to think about what we're doing along our transportation corridors and all of the planning that needs to be considered in order to make it successful for vehicle adoption. Next slide. So CalSTART, we're a clean transportation nonprofit organization. We've been working with over 270 member organizations to advance clean transportation. And one of the very important efforts that we've been focusing on is looking at how we can deploy clean vehicle technologies along transportation corridors. Well, since 2014, we've been working with the federal government, state agencies, utilities, industry, and community partners, looking at opportunities to evaluate infrastructure gaps along our transportation corridors, working with the federal administration on evaluating, as we're designating corridors for alternative fuels, where do we see those gaps? What do we need to do in order to successfully build the infrastructure necessary to realize our near to zero emission transportation future? Next slide. So there's two really important studies that we wanted to share with you that take a very important approach to infrastructure planning along transportation corridors for medium and heavy duty vehicles. The two studies that I wanted to share with you are similar in approach, but have different methodologies. The first that I would like to highlight is a project that we started with EPA, and a big shout out for my friend John Mikulin from EPA Region 9, is we worked through a multi-stakeholder partnership to evaluate infrastructure gaps along I-5 and all the connecting routes, starting from the border of Mexico all the way to the border of Canada, to really see what does it mean in order to advance clean transportation technologies across multiple fuels. And what was really interesting about this partnership is that we evaluated what are the priorities, what do we need to be thinking about in order to be successful at deploying infrastructure. What funding is required in order to successfully support fleets that need to adopt these technologies to have the funding necessary to support infrastructure development? Who are the partners we need to be working with in order to build out this infrastructure? And especially as we're looking at electrification, and we've heard it today, working with our utilities is going to be absolutely critical. So we actually reached out through this partnership and spoke with fleets, spoke with our infrastructure providers, our vehicle manufacturers, and we evaluated 147 sites along the West Coast corridors for alternative fuel infrastructure, including 62 sites for charging infrastructure. Now, this was looking at both depot charging, but also public charging. And we realized that there is a lot of good work that needs to be done, including evaluating how ready is a site. So our team, working very closely with EPA and through this multi-stakeholder partnership, evaluated all the criteria to understand what makes a site ready. So this was a great method for us to really understand what is the interest, what's the level of need, what do we need to have in place to support these fleets to be successful at deploying vehicle technologies, and realize that we're going to need not only partner collaboration, but we're going to need funding resources to really support being able to build out that infrastructure. The other study here, and this is really a fascinating study, working with Southern California Edison and 8 other utilities, including 2 agencies representing multiple municipal utilities, to evaluate what is the impact on the grid. If we are going to build out a zero-emission transportation corridor along the West Coast, looking at I-5, similarly to our other partnership with EPA, what is it going to take? What do we need to anticipate in terms of build out in order to support electrification, understanding the demand that it may have on the grid? So this study was taking more of a data-driven approach. Yes, we were working very closely with all these utilities, but we wanted to understand, where do we see and anticipate the transition of zero-emission vehicles? Where do we see traffic throughput in terms of where we should be prioritizing infrastructure, for example, at truck stops, and then understanding what's the current load and what additional load might we need in order to support electrification along I-5. And we saw an opportunity, if we were to plan over the next 5 years, for example, 27 sites along 1,300 miles for medium heavy duty charging. And then as we look at technology come online for fast charging for heavy duty trucks, looking at every other site location to place heavy duty charging technology to support a longer distance transportation with our semi trucks. So this gives you a good idea of what to plan in terms of corridor planning with partners, looking at a stakeholder-driven approach, as well as looking at the important data that's going to be necessary to be smart and strategic at making sure that you have all the resources needed in order to plan effectively. Next slide. Just a couple of other things that we were looking at as tools to really help inform how we approach corridor planning. CalSTART, we manage California Air Resources Board's Hybrid and Zero Emission Truck Voucher Incentive Project. And we've been working with state agencies, utilities, industry partners to evaluate the infrastructure gaps in California. And what we wanted to do was we wanted to look at, where do we anticipate vehicles being deployed through the incentive program, and what can we expect in terms of the power requirements that are going to be on the grid to support those fleets that are going to be deployed, and what their depots are going to need in terms of energy requirements. A part of that analysis is understanding how might we take that information to think about how we're planning our infrastructure along transportation corridors. So not only is California and the West Coast states taking a close look at this, in New York, they're also looking at planning and prioritizing infrastructure development along clean freight corridors. And some important metrics to really evaluate for are our communities. Where are we seeing transportation throughput along our corridors? How close and nearby are communities, and where should we be really prioritizing advancement of clean infrastructure to really enable near to zero emission transportation technologies? So really looking at a number of different factors, whether understanding what grid capacity is there, understanding where we see market projections and vehicle movement to prioritize locations of charging infrastructure, understanding how it impacts communities, and really putting that at the center of planning, making sure that we're helping to improve air quality in these communities, and really working through partnerships to make sure that we have everyone at the table that needs to be collaborating on advancing clean corridors. Next slide. So to quickly wrap up, and I know that Jesse's going to put the 2 reports that I referenced earlier into the chat so that you can download them and read them at your leisure. There's a lot of detail there, but just some takeaways here. Yes, we need public charging along our corridors to help enable the adoption of electric trucks. And we need to plan for electric corridors right now. And what's so encouraging is that we have so many great partners, including those that presented today, that are working hard on this so that we can realize that future of driving electric trucks along our corridors. Planning is going to require diverse partners. You need to bring your utilities, your industry, your communities, your fleets, your vehicle providers, your engineering firms to help out with the planning of corridors. And then equity should be at the center of what we're doing. We need to make sure that we're advancing clean technologies to build a brighter future and to protect our communities that are most impacted by transportation emissions. And then we need purposeful commitment. We need partners to come to the table with resources, with ideas and innovation to really realize the advancement of electric corridors for our trucks. So hopefully that gives you an idea of where we see the opportunity advancing public charging along our transportation corridors. And I look forward to taking your questions, and thank you again for the opportunity.
Thank you so much, Alicia. Very exciting stuff. Looking forward to seeing these charging stations built out along these corridors. And with that, we've got about 10 minutes left for Q&A. I can tell you charging infrastructure is absolutely the #1 topic that we get questions about here at NACFE on electric trucks. So we've got a ton today, it's no exception. I'm gonna start with some of the questions we received from registration. The first one, I got a couple different versions of this, is really around the electricity grid. How are utility planners as well as infrastructure suppliers going to be able to keep up with this demand over the next 20 years? We're talking about a lot of infrastructure. And I thought for this one, we might start with Joe as our utility rep on the call. Joe, what do you think? Are you guys worried about keeping up with this demand?
Yeah, great question, Jesse. And we kind of have a saying at PGE when we talk about delivering reliable and affordable electricity to our customers. We do this every day. And so every time there's a new data center, there's a new manufacturing plant, et cetera, we go through similar exercises that we're expecting as we see more and more heavy duty electric vehicle charging infrastructure to be deployed in our service area. That being said, this is unique new load to be added to our distribution network that has some really good attributes that we're really excited about. The fact that it's flexible, the fact that it could potentially participate in demand response, vehicle to grid, offers a whole nother dimension of utility services. But there may be some challenges as well where this kind of is intermittent load, and it's pretty new for us to see a megawatt and a half of load show up on our, drive around our grid, park, show up in one location, then maybe at another time show up in another place. So I'm confident in our ability to serve this load, and I think utilities in general are very well practiced at meeting new load requests. And I'm really excited with Electric Island, this kind of test bed for us to learn about the load profiles and about these opportunities to make sure that as these new loads come online, we're really getting the most out of them and the most benefits for our customers. So we're confident and we're excited to learn.
Thank you, Joe. Very, very reassuring there. And Peter, anything you want to add on the infrastructure provider side, given all your experience with the huge map of stations we saw earlier?
No, I think Joe did a great job. And first off, I share his optimism. I think that you've got a lot of smart people that are working on this, and I'm confident that the utilities are just as excited about this as the folks that are trying to deploy the technology. So overall, I'm optimistic. I think as the other folks on the call would agree, there's a scaling thing here where if you're talking about maybe 10 to 15 chargers at 150 or 350 kilowatts, in our experience, the utilities have been able to handle that. There's only one site that I'm aware of out of the 600 that we've had to launch with lower power levels than we planned. But when you're talking about megawatt charging, you're talking about supporting 50 trucks, then you're talking about substation level of power and service sizes. So in that case, just as Joe and I emphasized in our presentations, it's all about coordination early and often with the utility, make them aware of your projects as soon as you have the basic scope laid out so you can work together to get the service deployed to your site. And that may require phasing, a phased approach while they're working on the larger service sizes. But overall, I think that especially when we're talking nationwide, utilities are enthusiastic about these projects, and they're going to do what they can to get the electrons into the vehicles.
Great. Thank you, Peter. Another question I'm seeing a lot of different versions of is basically what standards are out there? Are we thinking about standardizing specifications for chargers, whether it's connector types, power levels? What's happening there? It's kind of the Wild West right now, it can feel like, but where do we see the industry going? Maybe Steve, I'll go to you first, and then Paul, I know you had mentioned some work with Charin around the ultra high power charging standards. Maybe you could talk to that next. But Steve, what are your thoughts there? I still can't hear you. Maybe we'll go to Paul first for the megawatt charging standard and come back to you.
Sure. Working from the top down. So I think that what's exciting about it is this is not really new. If you look at ships that plug in, you look at even rail applications, the amount of power that we're conveying into these larger vehicles, it's not really unique. But what's been missing is having, once you get above the 350 kilowatt, a plug configuration that's tested, that's safe, that's agreeable to vehicle OEMs, as well as industry for everything from touch safety to the parameters of having humans around these high power connectors. So to that, the Charin group has been working on it really diligently, I mentioned, since 2018, and moving that forward. And Steve mentioned about cooling cables and so forth. So those things really are not to be taken lightly. That we're moving a lot of energy, but I'm very, very optimistic and bullish on that for not only trucks, but aircraft, and potentially buses might deploy this as well. Steve's back. Oh no, okay, Steve, we cannot hear you, so I'm gonna just punt a little bit, but there are other standards that are broadly defined by the geography. So in North America, CCS has the American flavor. In Europe, there's CCS that has the European flavor. That are two of the leading contenders. In Asia, there is another standard, the GBT, that is more prevalent. And of course, Japan has the beginnings of CHAdeMO. So all of those things are starting to converge, but the key for fleets is you will, as a fleet operator, be pushing for interoperability across your vehicles, across your vehicle OEMs, so that's a predictable experience and investment in reducing stranded assets.
Thanks so much, Paul. I see we're running a little short on time, so I'll just run through a few that I've seen. If we didn't have time for your question today, please know NACFE will be doing an analysis of all the questions we've received, sharing some answers to some of these frequently asked questions. I've seen a couple great questions around who's going to pay for this infrastructure as it's built out, particularly the public chargers. I would direct you in particular to some of those reports Alicia mentioned that are in the chat. There's some great thinking in some of those around where some of this funding might come from. I've also seen some questions around, how can we train our team to prepare to work and maintain these chargers? I will note that our 6th of 10 bootcamp trainings will talk all about workforce development, training, and safety. So I encourage you to join that one. And I've also seen quite a few questions around basically resilience. I've seen a lot of questions around how we might integrate solar into this charging system. And if we could go to the next slide, that's actually a perfect transition here to note that our next bootcamp training, 2 weeks from today, same time, same place, will be focused on resilience as well as power management. So join us on May 18th. As a reminder, please complete the survey that should auto pop up as you close out here. It'll also be in an email that is sent after the webinar. That's where you'll also find the slides and a link to the recording. And then finally, a reminder, if you'd like to test your knowledge and earn your electric truck expert badge, be able to share that with your social networks online, you can go over to runonless.com, navigate to the page for today's webinar, and you should see a little button saying quiz available. You can go ahead and start there. If you haven't taken the quiz for bootcamp number 1, that is a great place to start. So with that, I just want to thank all of you for joining. Special thanks to all of our panelists. This is truly an all-star team. And I just really appreciate you all taking the time. We hope that you'll join us for the rest of the boot camp. And as always, if you've got any questions, feel free to reach out to me directly. Thank you again and have a great rest of your week, everyone.